Hi students, and we're going to take a further look at factoring trinomials. So there's two main types of trinomials we'll be factoring in grade 10. The first of we have already discussed are trinomials with a leading coefficient of 1. So for example, x squared plus 10x plus 24. The leading coefficient, that's the coefficient on the x squared term, is 1. So the second type is with a leading coefficient greater than 1. So for instance, here we have 3x squared minus 13x minus 10. So to take a look at how to factor a trinomial with a leading coefficient greater than 1, let's take a step back and see what binomial products give us such a trinomial. So let's take a look at this one. We have 3x plus 2 multiplied by x minus 5. So using FOIL to help us out, first, outer, inner, last, so we're going to have our first terms, 3x times x, our outer terms, 3x times negative 5, our inner terms, 2 times x, and our last terms, 2 times negative 5. So here's what we're going to get. 3x squared, that's from our first terms. Our outer terms is going to give us negative 15x. Our inner terms, positive 2x, and our last terms, negative 10. So putting this all together now, what we're going to have is 3x squared minus 13x minus 10. So remember, the job of factoring is to undo this process. So what we're starting at is, if I'm starting here, how can I get to this step here? So again, we're looking for two numbers, but we're going to start things a little bit differently. So kind of in the general abstract form, we can write any trinomial in the form of ax squared plus bx plus c. So the leading coefficient is a, the coefficient on the x is b, and our constant is c. So we're taking a look at a family of trinomials where a is not equal to 1 or 0. So it's any number but 1 or 0. In this case, a equals 3. So what we want to do is we're looking for, again, two numbers that multiply to make something and add to make something. So they're going to add to make your b value. They're going to multiply to make the value a times c. So let's take a look at this. So I need to find two numbers. These two numbers have to add to make negative 13, and they have to multiply to make 3 times negative 10, which is equal to negative 30. So let's take a look here. Because it multiplies to make a negative number, that means one has to be positive, the other has to be negative. And to multiply out, think about what this is going to give us. So one's positive, one's negative, and they add to make a negative value. That means that the larger number has to be negative. So let's think here. Well, the first thing that might come to mind is maybe negative 10, positive 3. These two multiplied together definitely give you negative 30. But if you add them together, you get negative 7. So that's not going to work. Well, what's another pair that multiplies to make 30? Well, for instance, I can do negative 15 and positive 2. Adding these together give my desired value of negative 13. Now here's where the big trick comes in. What we're going to do is we're going to break up our b value of negative 13x to be negative 15x and 2x. So this is what we're going to get. I'm going to rewrite this as 3x squared minus 15x plus 2x, x minus 10. So notice that I haven't changed any values. All I've done is I've expanded negative 13 to be negative 15x plus 2x. So let's take a look at our next step. So we've got 3x squared minus 15x plus 2x minus 10. And what we're going to do now is we're going to factor by taking out common terms. And I'm going to do it in a pair. So I'm going to factor these in the following pairs. I'm going to factor out the most I can from this pair on the left and the most I can from this pair on the right. So let's see what happens. Well, the most that I can factor out from this pair is a 3 and an x. They're both divisible by 3 and they both share at least one x. So what am I going to get when I factor these out? Well, 3x squared divided by 3x leaves me a single x, and negative 15x divided by 3x leaves me negative 5. So now, well, what's the most I can factor out here? Well, I can factor out a coefficient of 2, or a constant of 2. So putting that on the outside, 2x divided by 2 gives me x, and negative 10 divided by 2 gives me negative 5. Now, the nice part is we know that we're correct so far if what's inside this bracket looks exactly the same as what's inside that bracket. So that's the step that we're looking for. That kind of confirms that we're on the right track. If we don't get that, that means we have to go back and try again. So now we're going to use a little bit of algebra to help us out, and hopefully by the end of this video this step will become crystal clear. So I'm going to use a trick here, and I'm going to say let the value of x minus 5 equal a. So I'm going to rewrite this statement, and wherever I see x minus 5, I'm going to replace it with a. So I'm going to have 3x times a plus 2 times a. Now think about this. Can this statement be factored? Well, you bet. They both have an a in common. So I can factor out an a, and I'll get 3x plus 2. So all that we have to do now is substitute in the value that we had for a. So what we're going to get is the following. We had a is the same as x minus 5, so we had a multiplied by 3x plus 2. Replacing again a with x minus 5, we get the fully factored form. So I'm going to do another example with you here, and we're going to try doing this without the let statement. We're going to look for the pattern that happens. So let's start us off. First thing we're doing is I'm looking for two numbers. They're going to add to make negative 18, and they're going to multiply to make 8 times negative 5, which is negative 40. Okay, so two numbers that multiply to make negative 40 and add to make negative 18. Well, the only way to get two numbers to multiply to make a negative is if one's positive and one's negative. So let's think of the numbers that multiply to make 40. The first one that comes to mind might be, let's say, negative 8 and positive 5. So, but this one won't work because negative 8 plus positive 5 is negative 3. So let's think of another pair. What about negative 20, positive 2? Adding these together definitely gives us the negative 18 that we're looking for. So these two numbers are your key. And notice that these two added together equal the coefficient of your variable, just your regular variable. So I'm going to break up negative 18 into negative 20p and 2p. So this is going to be 18p squared minus 20p plus 2p minus 5. What we're going to do now is we factor these in pairs. And just as a note, you always want to have a positive sign between these, or the addition sign. It's one of our little rules. So just make sure that you're including any signs in front here. So far we've been lucky. I'm going to show you in the next example how we can do the same question even if we swapped the negative 20p and the 2p. So let's follow along here. So factoring out in pairs, what's the most I can factor from these two? So I want you to pause the video and try this one out on your own. So we're going to get 4p onto 2p minus 5 and plus 2p minus 5. Now notice that what's inside this bracket is exactly the same as what's inside this bracket, so we know that we're on the right track. So now we're going to try a factoring trick here. Remember that we can factor out whatever we want, and we could also factor out this binomial. So think about this. think about if this was already inside some brackets, right? Adding brackets like that doesn't change anything. Let's factor out this binomial. So I'm going to factor out 2p minus 5. Well, what's going to be left inside? Well, if I divide out 2p minus 5 from this monomial, all that's going to be left is 4p. What happens if I factor it out from this monomial? Well, anything divided by itself is just 1. So we're going to get 4p plus 1 onto 2p minus 5. And this is the factored form. Kind of a quick way that you can think about it is that when these two binomials equal the same, that's going to be one part of your final answer. The other part comes from the coefficients of those two binomials. So remember that this here is just a coefficient of 1. So let's try this trick with another example. So we've got a tough multi-step problem here. First thing that we can notice is that there's a common term that we can factor out. So first step is I want you to pause this video and to factor out the common term. So what are we going to be left with? We'll have 4 onto 6m squared minus 5m minus 6. So now let's make up our chart. I'm looking for two numbers. They have to add to make negative 5, and they have to multiply to make 6 times negative 6, which is equal to negative 36. So again, because I'm multiplying to make a negative value, one has to be positive, one has to be negative, and because they add to make a negative number, the larger of the two has to be negative. And this kind of shortens our list of possibilities. So let's think of numbers that multiply to make 36. Well, 6 times 6 won't work because if one's positive, one's negative, we're going to have 0. So let's try another famous pairing. What about negative 9 and positive 4? Multiplying these two together definitely gives you negative 36, and adding them together definitely gives you negative 5. So you can see the benefits of really knowing your multiplication tables here. So this is a key skill to have, and that's why I was stressing it so much at the beginning of our year. So now that we know our two main numbers here, what we're going to do is we're going to break up negative 5m to be negative 9m and 4m. So follow along here. So I've broken up negative 5m to be positive 4m minus 9m. So notice what happens here when we set up our brackets. And I always said we want to have a positive sign in between here. So you want to include the negative sign with the 9, and then we just put a little plus sign in here to help us out. So now we're going to factor out the most we can from here and the most we can from here. So pause the video and give that a try. So doing the first one, we're going to have 4 onto 2m onto 3m plus 2. Now remember, our goal is to get this binomial and this binomial looking the same. So think about this. We have to factor out a negative because these are both positive. So I can factor out a negative, but more than that, I can factor out a negative 3. So negative 3 comes out. So left inside, I have 3m plus 2. Closing up our brackets. So we know that we're on the right track because these two binomials are exactly the same. So now let's do our quick step. What we do is the first part of our solution are the binomials that are the same. So we have the 3m plus 2. In the second bracket go the coefficients. So I'm going to have in the second bracket 2m minus 3. And that is our final answer. So we're going to continue our practice with factoring trinomials whose leading coefficient is greater than 1. So let's start out with this case here. We've got 12m squared minus 52m minus 40. So the first step I want you to do is to factor out any common terms. Notice that there is a common term between these three. So pause the video and try that out. So what we should get is 4 onto 3m squared minus 13m minus 10. So now let's make up our list. I need a number, two numbers, sorry, that multiply to 3 times negative 10. So that's going to be negative 30. And they have to add to negative 13. So once again, because they're multiplying to be a negative number, one has to be negative, one has to be positive. And because they add to a negative number, the larger one is going to be negative. So in this case, what might spring to mind is, for instance, 3 and 10, but the only way they could add to make negative 13 is if they're both negative, and that's not going to work. So what about negative 15 and positive 2? Adding these together will definitely give you negative 13. So what we do now is we're going to split up negative 13m into negative 15m plus 2m. So give this step a shot on your own. So expanding out the negative 13, we're going to have 4 onto 3m squared plus 2m minus 15m minus 10. And now what we're going to do is we're going to factor this in pairs. Remember that between these two binomials, you always want to have an addition sign. So make sure to include any sign here with that term. So you always have to have an addition sign between there. Very crucial key. So what I want you to do is to factor out the greatest common factor between each of these binomials. So what we're going to get is 4 onto m onto 3m plus 2 minus 5 onto 3m plus 2. Now it's key to realize that because when you factor out an m from this first one, both terms are positive. If both terms are negative, then we have to factor out a negative. So that's a key thing to realize. So now let's use our trick. So what goes in the first binomial is our doubled binomial value. What goes in the second are the coefficients. So we have m minus 5, and there is our final solution.